Hello, and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy them. So check out Linode. With 200 gigabit private networking, scalable shared block storage, and a 40 gigabit public network, you've got everything you need to run a fast, reliable, and bulletproof data platform. If you need global distribution, they've got that covered too, with worldwide data centers, including new ones in Toronto and Mumbai. Go to dataengineeringpodcast.com/Linode today to get a $20 credit and launch a new server in under a minute. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, read the show notes, and get in touch. And don't forget to go to dataengineeringpodcast.com/chat to join the community and keep the conversation going. Your host is Tobias Macy, and today I'm interviewing Brock Noland and Jordan Birdsell about Apache Kudu and how it is able to provide fast analytics on fast data in the Hadoop ecosystem. So, Brock, could you start by introducing yourself?
Yep, I'm Brock Noland, and I'm a co-founder of PhData, and I've been contributing to Apache Kudu, for a very long time, since it was before it was even created publicly, and also co-author of the Getting Started with Apache Kudu book by O'Reilly, and been involved in the Hadoop ecosystem for quite some time.
And Jordan, how about yourself?
Jordan Birdsell, and I've been involved in kind of the Hadoop space for probably 7 or 8 years now, starting at State Farm, moving on through a couple other companies before coming into PhData. In that time, I became a committer and PMC member for Apache Kudu by creating the Python client for Kudu.
Going back to you, Brock, do you remember how you first got involved in the area of data management?
Yeah, I was working at Thomson Reuters, and ultimately what we were trying to do at that point was scale up a website that they have. So Thomson Reuters, one of their core businesses is legal research, and they had a very old, antiquated system, and they really wanted to revamp it so it felt a lot more like Google when you do legal research. And so, instantaneous results, like you search all the data with just natural language. And so we were basically taking this back-end search system, which is built very, very similar to how Google is built internally, and trying to scale it up like 100x. And so in order to do that, we had to take the performance metrics that the system, on how the system was performing, and also, honestly, just the log data, and have it so that we could run queries over that data very, very quickly. And the data was at such a large volume that we ran into Hadoop and started using Hadoop to store and analyze the data, versus we had been using Oracle Exadata prior to that point.
And Jordan, do you remember how you first got involved in the area of data management?
So I started my career at Geico about 11 years ago, working in their pricing systems. So that was kind of a mixture of both analytics and operational data management strategies. Then when I went to State Farm, I started in kind of a pure research capacity with advanced analytics and kind of what became the data science group. And then, continued on that path. And then even at State Farm, moved into sort of operationalizing data science applications and things to that effect. And then moved on to do effectively the same thing at Stanley Black & Decker, kind of with more of a cloud native approach.
So can you start by explaining a bit about what the Kudu project is and the original motivation for building it?
Yeah, I'll go ahead and get started on that. So, ultimately, what we found is there's a lot of use cases on top of the Hadoop platform. It's a very general platform used to solve a lot of different problems, right? And there ends up being just a lot of use cases that require, fairly rapid modifications. The kind of like first use case attached to that is slowly changing dimensions. So those are kind of like the least quick updates, I would say. And so they come in, daily or even monthly. And, ultimately what that requires is that we update some data in HDFS. And there's a bunch of tricks on how, or S3, HDFS, S3, Azure Blob Storage, whatever it is. There's a bunch of tricks to handle those. But those tricks lead to complexity. And that complexity inhibits the number of users that can actually use the platform. And so that was really kind of, one of the motivating factors for Kudu. And then another one is that you have all these IoT use cases or IoT-like use cases where, data is starting to come in as a slow trickle or a stream of data as opposed to, in micro batches or even large batches. And dealing with that kind of data, ultimately, if you stick it in HDFS or S3 or Azure Blob Storage, you have to compact that kind of data if you trickle it in. And those compaction jobs are, again, like just really boring to write, first of all, and result in complexity that limits the use case, limits the availability of the platform. And so like those two use cases, I think, are the really motivating factors for the platform.
Yeah, and I'll jump in there to just kind of reinforce that, kind of the original reason why I got involved in the Kudu project and why my company at the time, State Farm, was very interested in Kudu was for that reason alone, is the level of complexity that our ingest and ETL applications had grown to was just unmanageable. We were having a hard time, for one, getting, our existing data and ETL resources to convert over to this skill set. For one, because the applications were complex, but it was just a huge shift. But then just the amount of development hours we were spending trying to make all these complex architectures work when something like Kudu completely eliminates that problem.
And you mentioned the Hadoop ecosystem a few times and the fact that Kudu was built to fit a niche that the other components weren't quite able to achieve, at least in a single tool. So I'm wondering if you can talk a bit more about how it fits into the Hadoop ecosystem overall and some of the other technologies that it's more commonly used with.
Yeah, absolutely. So ultimately, Kudu is a storage system within the general Hadoop ecosystem. And so I mean that pretty broadly. There's a whole bunch of different components that are, in the quote Hadoop ecosystem, end quote. And this is a storage system. So it's a columnar storage system that complements HDFS. So like on top of HDFS or S3 or Azure Blob Storage, you'd put, like Parquet or ORC on top of those to get like fast columnar scans. And, and basically a competitor to that would be to use Kudu. And in that competitive landscape, it would replace both HDFS and also the columnar storage on top. So it's both like a format and also a storage system from a very high level perspective. So it takes care of the replication internally as well.
Yeah, and I would say too, there's also a little bit of overlap into HBase with random reads as well. But Kudu's main focus, I think, from a scan perspective, is on analytic scans. So that's where the HDFS and Parquet piece comes in. So
yeah, so but kind of like the overarching goal of Kudu is to be like almost as fast as like Parquet on HDFS for analytical scans, and then almost as fast as HBase for like single row gets and stuff. And ultimately, that kind of meet in the center of those two use cases or those two examples. There's a lot of use cases that fit there. And then, from a scan perspective, it's typically Spark or Apache Impala that are used to scan the database.
And in terms of other projects that sort of jumped out at me is in terms of being in a similar space, as I was doing some research to prepare for the show, it put me in mind of the Iceberg table format that's being built for hooking into the Hive Metastore and the Hive SQL interface. So I'm wondering if you can do some compare and contrast between the use cases that Kudu enables and what Iceberg is enabling, or are they just completely orthogonal to each other?
Yeah, good question. I can go first on that one. So yes, Project Iceberg or Iceberg and Hive Acid are kind of what I would call slow motion Kudu. So they're built for handling updates, really on that like slowly changing dimension side. So if you just have a trickle of updates and you don't care how quickly they're applied, that's really where they fit. So they're kind of similar ideas, but Kudu, because it also extends down into the storage layer, can handle a much, much higher volume of updates. And so, what we see is people often using either a partial SSD system or a full SSD host for storing Kudu data, and you're looking at tens of thousands of updates per second on that kind of host, in terms of possibilities. And so it's a much it's built to handle much more rapid inserts and updates than those systems. Whereas those systems are very similar idea, but really built for really slow moving data. And I think the tagline for Iceberg is something like, it's a table format for large, slow moving tabular data. And I think HiVast is very, very similar in that regard.
And in terms of the types of use cases and application and system design patterns that Koodoo lends itself to, I'm wondering, what are some of the ones that you've found to be the most commonly applied and some of the most useful?
Yeah. So I'll go ahead and give that a shot again. Jordan, please step in when you want. And so Koodoo is really, really good at IoT data. So what we see often is, and this doesn't have anything to do with updates, but what we see often is IoT devices in the wild, data streaming in, and very often there's someone that wants to perform per user queries on that data. So for example, customer service that wants to be able to look at a particular user and query that data so they can help that user on the phone. And then also, of course, you want to be able to do analytics on that data over time, across users, right? And so both of those use cases, Kudu is really, really good at. And so that's a really common, just home run use case that we see for Kudu, where you can store the data once and fulfill both those use cases, and data can be queried, seconds after it's generated. And then another one is you have some relational system and you want to basically, and this is pretty simple, but you want to basically mirror that relational system in your analytical system, but you don't want this lag. So oftentimes there's this lag where at night we do a batch copy of all the updates and stuff. Since Kudu can handle those updates in real time, we can mirror that relational system into the Hadoop platform, and it's up to the second, if you will.
I was going to jump in on that second one. So I've spent a lot of time in data science use cases, and specifically with data science, oftentimes Hadoop or the Hadoop ecosystem becomes kind of your general purpose application development environment or model training environment. And so these RDBMS offloads, if you will, or replicas kind of become quite critical to those projects. A lot of data science use cases use images and things like that, but they typically have to augment these use cases with relational data that's coming from the ERP system. So the ability to manage that from an IT perspective in a clean way is something that Kudu really does well.
And in terms of that replication, would you just be using a change data capture feed to be able to replay those events, or are there specific support for things like write-ahead log replication or the MySQL oplog replication for being able to populate those updates?
Yeah, so in terms of getting those updates in, that we really see that falling, kind of outside of Kudu in the tool space, and so things like stream sets or NiFi or Kafka Connect, all of those things are very common tools to ingest those CRUD operations, and then Kudu is just a way that we can really easily provide up to the second reflection of those CRUD operations.
And as far as the overall project design, I found it interesting that you decided to leave the interface as a set of language bindings and support the Impala SQL engine rather than implementing your own SQL interface directly in the project. So I'm curious what the motivation was for that design choice.
That's the great thing about the broader Hadoop ecosystem, is that there's, it's basically kind of like a deconstructed database, right? We've taken a database and pulled it apart so each individual component is separate. And So we can have something like Kudu come in and just implement, a pretty small external user, interface, and then we can integrate all the technologies on top of that one interface. So we don't have to do SQL, right? Because there's already, a whole host of SQL engines in the Hadoop platform. And so, I think that makes implementing Kudu a lot easier, and it makes it smaller and more focused, so it can really focus on what it does well. And so I think I guess I see that as a function of the Hadoop ecosystem, which is a dissected or dismembered database, if you will, versus the old world where we had fully vertically integrated databases.
And does that design choice make it then easier to join across the different data sources? So the rapidly updating information that's being stored in Kudu and some of the more slowly changing dimensions that would be accessible via Hive or HDFS or HBase?
Yeah, I would say absolutely. So, by using something like a query engine like Impala that can access all of those different storage layers, and Kudu included, or HDFS, it enables that query engine, and that project team to access and join those disparate data sources together. Whereas had Kudu developed their own query engine, that may not have been as likely.
Yeah, and I think that you can very easily, especially with customers that are in the cloud, you can see this pretty clear storage hierarchy where it's data that's changing or that's being ingested rapidly makes a ton of sense to be in Kudu. And then data that is gonna be scanned, but isn't updating and isn't being ingested concurrently. That's really like an HDFS and Parquet/ORC use case, right? And then from an archive perspective, data that's going to be queried periodically, you've got S3, which is quite a bit more latent from a query perspective. And then even with S3, you can basically get cheaper storage by degrading your access to that data. And then all of that whole spectrum can be accessed with Impala and Spark.
And in terms of the overall architecture of the Kudu project, can you dig through that a bit more and explain how, for instance, the storage layer is architected and implemented, and some of the design choices that have proven to be most beneficial, and then some of the overall evolution of the system from when it first began to where it is now?
Yeah, so one thing that's changing quite a bit within storage architecture is that disks are becoming much faster from a seek perspective, right? So we've got SSD where seeks are very very low cost, and then you've even got newer memory/disk type technologies like 3D XPoint by Intel. And so ultimately, the big reason why you in the past wouldn't necessarily have a columnar database that you could update at a very high rate is because of disk seeks. And so ultimately that's not a bottleneck anymore. And so Kudu is a full columnar database under the covers, and is really built with the best of breed columnar encodings and compressions, so forth and so on internally. And you can have a true columnar database that you can go and update a single row or get a single row very, very efficiently because of that change in underlying storage technology. And so, that's one of the key kind of underpinnings from an architectural perspective that Kudu is based on is kind of this underlying change in storage. And then another piece is that if you look at CPU performance, single core CPU performance, it's ultimately kind of flatlining. We're not, Moore's law is dead or dying, right? And so what very likely comes out of that is that single core CPU performance for a project is going to, for software is going to become increasingly more important, as time proceeds. And so Kudu was implemented in C++ and has the ability from a roadmap perspective to take down projections and filters from a query engine, so it can actually apply them within the storage layer as native code. And so, those two things I think are two kind of like underlying primitives that required building a different database. You couldn't really do those things in an existing database.
And then to kind of compare it to some of the other things that we've been talking about, so like it's on disk format. Kudu kind of resembles Parquet, I guess you could say, or is very similar. There's some distinct differences, though, particularly when it comes to kind of enabling the random reads, like we talked about, so that it can kind of perform similar to HBase for the random reads. But yeah.
Yeah, the other thing, it's often in the same conversation as HBase, and a lot of people feel or think of HBase as like a columnar database, but ultimately it's not. So you basically end up creating in HBase a column family, and that column family stores a whole bunch of columns. And then if you read the HBase best practices, they say don't create too many column families. So you can't like create a column family per column. And ultimately what that means is you're storing a whole bunch of columns together that aren't the same type. And you can't get these you can't get these extremely efficient, you can't apply these extremely efficient columnar encodings on top of HBase for a whole host of reasons. One of them being that it's actually not a columnar database; it's a column family oriented database, which means it's more similar to a row oriented database than a column oriented database in practice. And that same thing applies to Cassandra as well.
And you mentioned that the implementation for Kudu is done in C++, whereas a lot of the other ecosystem components for Hadoop in particular, but also the broader big data ecosystem, has generally been Java or at least JVM runtime languages. So I'm curious what led to the decision of using C++ for the implementation target, and what you found to be the impact in terms of system efficiency, but also development velocity.
Yeah. So Kudu, the server component of Kudu, is implemented in C++. There's also a C++ client. So Impala, for example, is probably the most prominent user of the C++ client. There's also a Java client and a Python client as well. And from a client perspective, you can kind of choose any language. Obviously, the JVM language is included in that. In terms of choosing C++ on the back end, really the driving force behind that was CPU efficiency. If you look at the trends in CPUs, it's ultimately the performance is leveling off, and so single core CPU performance is increasingly becoming important. And if you look at if you spend, there's a lot of kind of, junk benchmarks, I guess, on the internet. But if you spend time really doing a strong benchmark of Impala which is implemented in C++, versus the JVM-based languages, you can see, or JVM-based SQL engines, you can find places where pretty easily where you see that impact from a CPU perspective. And so I think that was really important. Another piece is with HBase, for example, you just spend a lot of time doing, and all the SQL engines too, you spend a lot of time doing you end up spending a lot of time doing JVM tuning. And, it's a problem that's always kind of getting better, but has never really gone away. And so for us as operators of the Kudu platform, we just spend a lot less time thinking about the JVM. And I think that's been a huge operational win as well. And then another piece, I guess, is that like if you run a Koodoo or a Cassandra system, you think about compactions more than you would like. And so Koodoo has a pretty novel philosophy of from a compaction perspective. And, ultimately it's kind of like always be compacting. There's an internal algorithm that's used to decide if the benefit of a compaction is greater than the cost. And so from our perspective, we've seen that, we don't have to think about compactions very much with Kudu either. We've seen that be a big win as well.
And Going back to the storage layer, I know that Kudu supports clustering across multiple instances, so I'm wondering how that manifests as far as replicating data across nodes and some of the complexities or challenges that you've faced in the process of building out those capabilities.
Yeah, absolutely. So internally, Kudu uses Raft. So it uses Raft for replication across nodes. So the typical pattern is that you have a table in Kudu. That table is partitioned by some key, either a range or hash or both. And then those tablets are replicated 3 times using the Raft protocol. And Jordan, I definitely don't want to take credit for that or a lot of the early work. We're both contributors, and he's a committer to the project, but other folks were definitely doing that work. But what we see there is that ultimately when you do an update or you do an operation on top of Kudu, if you haven't configured your client otherwise, you're going to wait until the data is committed to 2 of the 3 nodes before it's successfully considered committed. And so the level of safety is a lot higher than with HDFS. So HDFS ultimately does not use a quorum to replicate data internally between the 3 nodes. And S3 is a little bit different, but ultimately your safety of your updates is quite strong. And we found that people are less surprised by the way Kudu behaves than with S3 or even HDFS. There's less times when people are like, oh, I lost the last 10 seconds of data. That surprises me because the guarantees, I think, are a little more aligned with human expectations.
And in terms of the Raft protocol for the consensus and clustering algorithm, I know that there are a number of other projects that have relied on things like Zookeeper for managing the overall cluster state and things like leader election. So I'd be interested to hear about some of the discussion that went into deciding on Raft as the consensus algorithm and some of the overall benefits that it has provided compared to some of the other solutions that were put forth.
Yeah, so with with Zookeeper, you can use Zookeeper to elect a leader, right? But when you do that, you also need to make sure that the storage, wherever state is stored, because people typically don't store large volumes of state in Zookeeper, you need to make sure that state is protected as well. So you really need to elect a leader and then also deny all possible previous leaders from updating the state. And so sometimes people will use Zookeeper with a stoneth, which is, shoot the other in the head when you take over as leader type technology. And I think, Todd Lipcon, the creator of Koodoo, right before he implemented Koodoo, he implemented name node HA for the HDFS name node and spent a lot of time looking at stoneth and other approaches for fencing that storage from, previous leaders who may not have realized they're not leaders anymore. And decided that using Raft for both leader election and then also replication of data was a stronger approach to providing availability and consistency. And so, Zookeeper the long story short is that Zookeeper solves one problem, the leader election. But then you also need to do storage fencing. And those 2 things are very, very related and, have a lot of interdependencies. And so implementing Raft themselves was, since they were going to have to do the data replication anyway, made a lot of sense to the Kudu team.
And it also has the benefit of being one less component that you need to build out and maintain and scale independently from the Kudu system that you are actually primarily caring about. Unless you're already running Zookeeper for other systems, it's just more headache and operational complexity that's not necessary.
Yep. I think that makes a lot of sense. And, if you're, there's certainly a lot of users that are going to be running the full stack of Zookeeper, HDFS, Yarn, so forth and so on, along with Kudu and Impala. But there's also users out there that use Kimpala, which is really just Kudu and Impala together. And having those users have yet another service dependency as well wouldn't be great.
And in terms of ingestion of data into the Kudu system, do people primarily just use the language APIs that are exposed in Kudu, or would they generally use Impala as the mechanism for executing insert statements, or is it just very sort of diverse range of approaches to building on top of Kudu?
So I'll speak from more of the data engineering side, and then Jordan, you can speak from more of the data science side. And so Impala can do inserts into Kudu, but like Impala is a big MPP query engine. And so it's not, if you're going to do like single row inserts, it's not the most efficient approach. If you're going to do single row inserts, typically you're going to use either the client API, Java, C++, Python, or a tool that's built on top of that. And so like most of the Kudu data that we're aware of is actually ingested with stream sets. So with stream sets, you have a visual editor, it's an ETL tool, right, where you can ingest data from a ton of different sources. And without writing any SQL, you can dump it into Kudu. And so that's a really, really common approach for users. The other probably second most common approach that we see is for IoT type use cases. You would, your API, your microservice or whatever it may be that's serving those IoT type clients, it would use that API directly. Typically the Java API, I think across the APIs, the Java API is by far the most used, either through Scala or through Java directly. And it's just interacting with Kudu directly. So I'd say that's the most common approach. Impala will also be used maybe if you're populating a table from sometimes in a workflow, you'll be populating a Kudu table from Parquet. And that'd be a great use case for Impala to do that work.
And so on the data science side, largely depends on who's doing the ingestion, but oftentimes data scientists are going to do some of their own ingestion. So Impala becomes kind of more prevalent there, just because data scientists typically are a little more comfortable with SQL than say going in and using Java or C++ directly. Of course, we have the Python API as well. However, this is probably one of my regrets in writing that, is that I kind of stuck with the same semantics that the C++ client uses. So as a side note, the Python client using Cython just wraps the C++ API. But the semantics of doing writes through the Python client are admittedly a little engineering-like feel. I did some effort to wrap those and give it kind of a Python feel, but ultimately it's not as comfortable as say something like giving them a pandas like feel to a client. But
yeah, another thing I'd say, I would be remiss if I didn't mention Spark. Spark is kind of what I consider the default ETL tool for big data, and so lots of Spark Kudu ingestion work going on as well.
And your comment about the Python client brings up the question of some of the challenges or overall incentives for keeping the different language interfaces feature complete in relation to each other, and the overall design approach to make sure that it's easy to use any of the different language runtimes, but also make them fairly idiomatic for the language that you're targeting.
Yeah, and honestly, that's being so Java and C++. Well, Java is actually an entirely separate client, whereas C++ and Python are kind of bound together pretty closely. But feature parity has been keeping feature parity has been pretty high priority, and mostly what I kind of deal with at this point, given that the Python client's created, but just keeping that up to speed. And then the other piece, like you mentioned, is keeping it aligned with kind of the natural feel for those languages, and that's been a challenge too. I can't speak as much for say Spark and some of the others, although I've done Apache or two, but in Python particularly, trying to keep it in line with kind of the Python way has been a challenge. But and again, like I said, that one of the regrets is not changing that direction early on. But ultimately, a lot of that can be addressed through just a kind of functional layer on top. So
And in terms of deployment and maintenance of Kudu, I know that there's been a fair amount of focus put on enabling operational simplicity in terms of actually getting it deployed and maintained, but also in terms of observability for the system. So, can you talk through some of the capabilities of Kudu that simplify that overall process and what's involved in actually getting it deployed, and also some of the upgrade life cycles that you might have to undergo?
Yeah. So in terms of installation upgrades and stuff, for the most people just use Cloudera Manager to do that. And it's really, really slick, very easy to do. In terms of things that I think Kudu's done really, really well, like in this general area, is on the observability front. There's with C++, things like stack traces typically aren't implemented. There's typically no real good way to get, stack traces from a C++ process. And so they've instrumented Kudu and have the ability to do that. I think honestly, there's lots of fancy observability stuff that's super valuable in Kudu and also coming out generally. But when you have a process and you can just say, you know what, give me 10 stack traces in a row once a second, that right there is just so valuable that you can understand what's going on, what's expensive. And so that's a feature that is absolutely invaluable. On the metric side, they've done a ton of work to make sure that Kudu is providing the metrics that are important around managing that platform. And also instrumenting the memory allocator. So you can very, very easily figure out where is memory being allocated, who is using memory within a process. So a lot of I've always said, the thing about the JVM that's so awesome is that it's so transparent. It's easy to figure out what's going on inside of it. And they've spent, because of their decision to use C++, have spent a lot of time replicating a lot of that transparency inside of Kudu. And I'm personally big on that. And, for not being a JVM project, I think that Kudu is really the most transparent process that I've ever operated before. So props to Todd for setting that direction early on. And for me, it's given what it's doing and given the scale that we have customers running it at, it's just not that big of a headache. In terms of, you kind of mentioned upgrades, I guess. The early versions of Kudu, when it was, 1.0 through 1.3, which, I don't know, is a year or 18 months ago now, there were some definite challenges with upgrading and using those systems. But today we push out Kudu updates to customers without a lot of worry, and it's a very, very easy process to do that.
And in terms of the overall system design, are there any particular edge cases that you have found to be problematic or that would be useful to have a heads up about for any new users? And if you were to start the entire project over today, what are some of the aspects of the system that you would design differently?
So I think the number one is that, let's say you have a table and you want to reload that table. What you don't want to do is go and do a delete on all the rows in the table and then re-ingest. You'd prefer actually to drop the table, recreate, and then re-ingest. And ultimately it's because Kudu's got to sort through all those delete operations in order to scan to scan the table. And so there's work to improve how that behaves. And I think even some has made the latest release, but today, you just definitely don't want to do that. Just drop the table and recreate it. And that's hit a number of people. That's probably been the biggest gotcha, I think, that people have found. And then I guess go ahead, Jordan.
Oh yeah, I was just going to say on the analytics side, as an example, a lot of times the data sets that we use are really, really wide. And, Kudu doesn't handle these incredibly wide tables very well. So a lot of times we have to chunk those up or kind of get them back into a denormalized state. But, really, once you go beyond 300 columns or fields, it becomes kind of complicated. But, I've seen use cases, and this is going to sound ridiculous, where we have up to 15,000 columns, to try and build a predictive model from. So those kinds of use cases are challenging. in Kudu.
Yeah, and then the only other thing I'd say is that I wouldn't say that I can think of something that like definitely do differently. Well, I mean, kind of, I guess. So ultimately, like until, even today, the security around Kudu is very, very coarse grained. Like you can write to Kudu or you can't write to Kudu. And so it's really, really coarse grained. And so there's work going to integrate Kudu with Apache Sentry, so you can do role-based access control on a per table basis. And if I could have changed anything, like I would have prioritized that work earlier on. And so there's been a number of use cases where we haven't been able to use Kudu, and it would have simplified things. Because of that really, really coarse-grained security. So having that prioritized earlier, I think would have been nice. But that's really kind of the only piece that I have, or complaint I have, I guess.
I agree.
And so with that in mind, what are some of the situations where you would advise against using Kudu, whether because of those security restrictions or just in terms of the overall system attributes?
So to be clear on the security end, a lot of, we'll call it the access patterns for utilizing data within Kudu. So ignoring the ingestion for a moment, go through Impala. So meaning data scientists or business analysts come in and use Kudu data through Impala. And so Impala is integrated with Sentry, and the data can be secured at a role-based level that way. The situations where it's not is when you're going through one of the client APIs, Java or Spark or Python or what have you. So these are the situations where that becomes an issue. Generally, what we've seen people do is just force everyone through Impala where you can, and then whitelist use cases essentially to the API where possible. Brock, did you want to add to that?
Like most of the time we can work around it, using that approach that Jordan mentioned. But I think it'd be more ideal. Like the security is coming, and it would have been better to have it, earlier. Is kind of what I'd say there. In terms of use cases where Kudu doesn't really make sense, if we have, like, for example, Kudu has a string and has a binary type, but right now the default max size is 64K. And so if you're bringing in big blobs, big images, things of that nature, it doesn't really make sense to put that, or can't put it in Kudu. You probably don't need that in a column-oriented database. So we have a number of use cases where we'll bring that blob in as a side channel, put it somewhere, and then put the rest of the table in Kudu. And then, another use case is if we talked about changes, dealing with CDC type data, right? Continually changing data. Well, just like with the deletes, as I mentioned, like if the whole data set changes every day, that's a problem as well because of the way Kudu is internally architected. And some of those things are being improved, but that would be a use case where we'd want to spend a lot of time thinking about how to architect that. Because by default, it wouldn't work very well out of the box.
And in terms of your own experiences working with Kudu and building on top of it, what have you found to be some of the most interesting or unexpected or challenging lessons learned?
Yeah, so just this is kind of more of a personal note, but this was for me my first open source project, really being like heavily engaged in, and all the while I was doing that at it while working at a company who was financial based, so they had a lot of strict intellectual property rules and stuff, and none of this really has to do with the project, but it was an interesting experience for me, learning to get through all of that, and kind of my first journey into open source.
Yeah, I'd say two things. So first, on the lessons learned or whatever, I'd say initially Kudu was really architected at these really, really long tables, really, really large tables that are used for IoT type use cases, and it excels at that. But because of the there's so many enterprise data sets in all these companies that are constantly changing and stuff, it's really, really useful to use it to be the storage layer for just constantly changing enterprise data sets that maybe aren't a billion rows or 100 billion rows, and been constant improvements in Kudu for that use case. But it was kind of something that the Kudu team didn't really see out of the gate. And so, it always helps to get in front of users, and certainly the Kudu team did this, but get in front of users and try and understand how they're going to use the technology. And, I think that was just an insight that was a little missed out of the gate, I guess. And there was some work to kind of catch up with that use case. Yeah, so I guess lesson learned is, always get out in front talk about use cases as a community, get out in front of users and understand how they're thinking about using the platform, a broad spectrum of users. And then, I guess in terms of things that I'm really surprised by or proud of, or, kind of all combination of those, all or peer SSD boxes are becoming really common because of the cloud. And it's amazing the throughput that Kudu as a pure columnar database can do on top of a peer SSD box. In AWS, for example, it's really amazing to have a truly pure columnar database and yet have just amazing throughput in terms of CRUD operations per second. So that's really cool to see. I think that's kind of seeing the future a little bit when working on those use cases.
And what are you most excited about for the future of Kudu in terms of new features or improvements or just overall community adoption or anything along those lines?
The first thing I'd say is kind of one we already talked about, which is kind of that finer grained access controls, which is coming through Sentry integration. That's being worked on as we speak. And I would hope, this isn't like an official statement, but I would hope that would be completed, end of Q1 or maybe even early Q2. And I think once that's released, that the barrier to entry for most large enterprises is going to be eliminated. So, the ones that haven't joined in, that's been a big problem. So I think once that's gone, that we'll see a lot more adoption of Kudu, and I look forward to that.
Yeah, and I'd say from my perspective, we've been really involved in the community since the very beginning. And so minus the security piece that Jordan just mentioned, I really feel that it's in a place where adoption is starting to drive upwards, and I think that's going to continue. And so I'm really excited to see more and more use cases be implemented on top of Kudu and in the growing community of Kudu.
And are there any other aspects of Kudu or fast analytics or the Hadoop ecosystem or anything else that we didn't cover yet, which you think we should discuss before we close out the show?
No, I think we did a good job. And so, yeah, I would just encourage folks to try Kudu and bring the feedback to the community. It's got a very active Slack channel where you'll find the original authors and contributors and committers like Jordan and myself, along with a large number of users as well. So give it a try and reach out with questions.
All right. Well, for anybody who does want to get in touch with either of you and follow the work that you're up to, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today. We'll go with you first, Brock.
Yeah, I think Jordan's going to speak the same. So I'll just say, give it a short sentence. But what we see right in the future is that, there's a bunch of machine learning models being used to help to really make decisions for businesses, right? And like if you look inside Google or you look inside Facebook, ultimately there's a lot of production machine learning model. And we really believe that's going, the enterprise is going to have a lot of production machine learning models in the future. And yet, if you talk with, a lot of our customers, or prospects, like there just isn't any machine learning models in production. In fact, a lot of them don't know they have to do that. And so to me, that's kind of the glaring gap in the ecosystem. And I'll let Jordan finish it off. It's really his space.
Yeah. So that's largely what my team's focused on here at PhData. But I'd say from a tooling perspective, there's a few gaps. One, there's really no one platform for this, right? There's a lot of people trying to address it in little minute areas with kind of push button solutions to go to production, and inevitably those types of solutions just don't work for large enterprises, Fortune 500, and so this is a challenge, right? So that puts you back to like basically these really complex ecosystems where you kind of have to string together a bunch of tools, kind of like how Hadoop would have been pre-Cloudera. The challenge is right now is that we don't have anyone really stringing those together. So that's something that we focus on, as well as kind of the engineering gap I also feel there's a kind of a gap in skills between, say, a data scientist and a data engineer, kind of falling into the machine learning engineer space, and that's that prevalent of a role yet in the market. So, but it's on the upswing, so I think things are looking good there. And then the other thing I would say, these are these are kind of like old ideas and things that there's been tools out there for a while, but I feel like they're not evolving as quickly as say some of the other components, and that would be kind of in the space of data quality and data cataloging. And again, there are people like Calibra and others that are coming out with stuff, but I still to this day am seeing a lot of clients, large clients, develop their own solutions for these, and I just feel like there could be better frameworks in place. But yeah.
Well, thank you both for taking the time today to join me and discuss your experiences working with the Kudu platform. It's definitely a very interesting project and one that seems to have a very well-defined place in the Hadoop ecosystem. So thank you both for the time and effort you put into that and for your time today, and I hope you enjoy the rest of your day.
Thank you.
Yeah, thanks.